Good evening, and welcome to the Sleeping Zoo. Facts to fall asleep to. The story of the Peregrine Falcon is a narrative of planetary dominance written in the language of high-velocity physics and biological precision. To understand this bird is to understand the very limits of what a vertebrate body can endure while maintaining a state of calculated, lethal intent. We begin our examination not on a single continent, but across the entire map of the Earth, for the peregrine is the most widely distributed raptor in existence, appearing on every landmass except for the extreme polar regions of Antarctica and the most remote oceanic island chains. Its name comes from the Latin word peregrinus, meaning wanderer or pilgrim, a title that captures the essence of a species whose life is defined by the vastness of the horizon. The taxonomic breadth of the peregrine falcon is a testament to its versatility. With 18 recognized subspecies currently inhabiting a staggering variety of ecosystems. These range from the tundra peregrine, which breeds in the treeless Arctic and migrates thousands of miles to the southern hemisphere, to the Peale's falcon of the Pacific Northwest, a massive and dark-plumaged specialist of the maritime environment that often remains on its territory year-round. There are the smaller, swifter subspecies like the Brooks falcon of the Mediterranean and the desert-dwelling Barbary falcon, which some authorities argue is a distinct species entirely. Each of these variations represents a fine-tuning of the falcon's basic blueprint to meet the specific demands of its local climate and prey base. The tundra peregrine provides perhaps the most dramatic example of the wandering nature that defines the species. These birds are among the most impressive long-distance migrants in the avian world, often traveling more than 15,000 miles in a single year. They spend their short, intense summers in the high Arctic, where the 24-hour daylight allows for constant hunting to sustain a rapidly growing brood. As the northern autumn approaches, they begin a journey that carries them across the breadth of the Americas, over the Caribbean Sea, and deep into the tropics of South America, with some individuals reaching the tip of Argentina. This migration is not a casual drifting, but a high-stakes endurance feat, requiring the falcon to maintain peak physical condition while navigating changing weather patterns and varying prey availability across two hemispheres. As we move from the global scale to the microscopic, we find that the peregrine's physical form is a masterpiece of aeronautical engineering. Every feather, every bone, and every specialized cell is oriented toward a single goal: the mastery of the vertical dimension. While many birds are fast in level flight, the peregrine has evolved to exploit gravity as its primary engine. This capability centers on the stoop, a high-speed diving maneuver that is widely considered the fastest movement performed by any animal on the planet. To achieve speeds that can exceed 240 miles per hour, the falcon must undergo a radical physical transformation mid-air. When a peregrine initiates a stoop, it does not simply drop. It enters a state of controlled collapse. It begins by tucking its feet tightly against its undercarriage and folding its wings into a precise teardrop shape. In fluid dynamics, the teardrop is the most aerodynamic form possible, minimizing the wake and turbulence that would otherwise slow the bird down. By reducing its surface area and smoothing its silhouette, the falcon effectively negates the resistance of the air, allowing gravity to accelerate its mass to terminal velocity. This is not a passive fall, but a highly active process of steering. The falcon uses subtle adjustments of its tail feathers and the slight flexing of its wingtips to maintain its trajectory toward a target that may be miles below it. The stresses involved in such a dive would be catastrophic for a typical biological system. At 200 miles per hour, the air pressure hitting the falcon's face is immense, yet it must continue to breathe to fuel its high-revving metabolism. Evolution has solved this problem with a piece of engineering that preceded human jet engine design by millions of years. Inside the nostrils of a peregrine falcon are small, bony structures known as tubercles. These act as baffles, breaking up the incoming high-pressure ram air and creating a series of vortices that slow the air down before it enters the lungs. Without these tubercles, the pressure of the air at those speeds would simply burst the falcon's delicate respiratory membranes, effectively suffocating it even as it moved through a sea of oxygen. This mastery of pressure is accompanied by a mastery of vision. To hunt at such speeds, the peregrine requires an optical system that functions with the resolution of a high-powered telescope and the processing speed of a supercomputer. The eyes of a falcon are proportionately massive, occupying a significant portion of the skull. They are equipped with a high density of photoreceptor cells, particularly in the foveae, the areas of the retina responsible for sharp central vision. Unlike humans, who have a single foveae per eye, the peregrine possesses two. This allows it to focus on objects directly in front of it, while simultaneously maintaining high-resolution detail on objects to the side. This dual foveal system leads to one of the most fascinating mathematical behaviors in the animal kingdom, the logarithmic spiral. When a falcon spots a potential target from high altitude, it rarely flies in a straight line toward it. If it were to fly straight, it would have to turn its head to keep the prey centered in its high-resolution, lateral vision, and turning its head at high speeds would create significant aerodynamic drag, slowing the dive. Instead, the falcon keeps its head perfectly straight and follows a curved path, a spiral, that keeps the prey in its lateral field of view at a constant angle. This spiral is a perfect mathematical curve that allows the bird to maintain maximum speed while never losing sight of its meal. It is a breathtaking synthesis of geometry and predatory instinct. As the falcon nears the end of its dive, the focus shifts from the physics of the fall to the mechanics of the impact. The peregrine does not typically grab its prey mid-air with open talons. The speed of the collision would likely break the falcon's own legs. Instead, it uses a closed fist strike. It punches its prey with its rear talons, delivering a blow of such concentrated kinetic energy that it can decapitate another bird or snap its spine instantly. This impact is often followed by a rapid pull-out maneuver where the falcon must endure G-forces that would cause a human pilot to black out. The falcon's skeletal structure, particularly the massive keel bone of the sternum, provides the necessary anchor for the powerful pectoral muscles that must snap the wings open to arrest the fall and bring the bird back into level flight. If the initial impact does not kill the prey instantly, the peregrine employs its most specialized anatomical tool, the tomial tooth. This is not a tooth in the mammalian sense, but a sharp, triangular notch located on the upper mandible of the beak, which fits perfectly into a corresponding groove on the lower mandible. This notch is designed for a single purpose: to slide between the vertebrae of the pre's neck and sever the spinal cord with a quick, decisive bite. It is a tool of surgical precision that ensures a rapid end to the hunt, minimizing the risk of the falcon being injured by a struggling victim. The energy required for these feats is provided by a respiratory and cardiovascular system that is arguably the most efficient in the world. Birds possess a one-way respiratory system, where air flows through the lungs in a single direction, assisted by a complex series of air sacs. This means that unlike mammals, who have dead air left in their lungs after an exhale, a bird's lungs are always filled with fresh oxygen-rich air. In the peregrine, this system is tuned to the highest possible frequency. During a steep climb to altitude that precedes a hunt, the falcon's heart can beat several hundred times per minute, pumping oxygenated blood to the pectoral muscles with incredible efficiency. This allows the bird to sustain a level of exertion that would lead to rapid muscle failure in almost any other creature. The internal life of the peregrine is further supported by the pecten oculi, a comb-like structure of blood vessels inside the eye that is unique to birds. In the falcon, the pecten is highly developed, providing the retina with a massive supply of nutrients and oxygen without the need for a dense network of blood vessels that would obscure its vision. This allows the falcon to maintain its extraordinary visual acuity even during the most physically demanding parts of the hunt. It is this combination of specialized structures, the tubercles in the nose, the tomial tooth on the beak, the dual foveae in the eye, and the one-way flow of the lungs, that transforms a simple bird into the most formidable kinetic weapon in nature. Beyond the biological, the peregrine falcon has occupied a central place in the human imagination for thousands of years. It was the noble bird of the Middle Ages, a status codified in the Book of St. Albans, which dictated that the peregrine was the proper bird for an earl, while the gerfalcon was reserved for kings. This was not merely a matter of prestige, but a recognition of the falcon's temperament and skill. The peregrine is a bird of the open sky, requiring vast spaces and a handler with a deep understanding of avian psychology. In ancient Egypt, the falcon was the living embodiment of the god Horus, the sky god whose right eye was the sun and whose left eye was the moon. To the Egyptians, the falcon represented divine transition and the power of the sun, a soaring bridge between the earthly realm and the heavens. The transition from the ancient Egyptian sands to the high-altitude theaters of modern evolution reveals a bird that has refined its internal chemistry to match its external velocity. To sustain the explosive power required for a vertical climb, the peregrine falcon utilizes a metabolic engine that operates at a level of efficiency rarely seen in the vertebrate world. This begins with the composition of its flight muscles, specifically the pectoralis major and the supracoracoideus. These muscles are composed almost entirely of type 1 fast-twitch oxidative fibers, which are packed with mitochondria and myoglobin. This cellular specialization allows the falcon to process oxygen at a rate that prevents the buildup of lactic acid, enabling it to maintain a high-frequency wing beat for extended periods without succumbing to fatigue. The skeletal framework that supports these muscles is equally specialized, centered on the furcula or wishbone, which acts like a spring storing and releasing energy during each stroke. In the peregrine, this bone is exceptionally robust, providing the structural integrity needed to withstand the massive torque generated by the pectoral muscles as they pull against the air. This internal tension is further managed by the uncinate processes, small, bone-like tabs that extend from the ribs and overlap with the rib behind them. These processes serve to stiffen the entire rib cage, preventing the bird's chest from collapsing under the immense atmospheric pressure experienced during a 200-mile-per-hour dive. This architectural rigidity ensures that the respiratory system remains fully functional, even when the bird is subjected to multiple gravitational forces during a high-speed pull-out. As we look closer at the respiratory cycle, we find that the peregrine's air sacs do more than just facilitate a one-way flow of oxygen. They act as a sophisticated cooling system. Because the falcon's metabolic rate is so high, it generates an enormous amount of internal heat. During a hunt, its core temperature can rise to levels that would be fatal for most mammals. The air sacs, which extend into the hollow cavities of the larger bones, allow for internal evaporative cooling, effectively dissipating heat from the inside out. This thermoregulation is critical, as it prevents the falcon's brain from overheating during the intense mental and physical exertion of a pursuit. This mental focus is governed by a neurological system that processes visual information at a speed that makes human vision seem sluggish. The flicker fusion frequency of a peregrine falcon, the rate at which its eyes can perceive individual flashes of light as a continuous image, is significantly higher than our own. While a human might see a blur when an object moves quickly, a falcon sees a series of distinct, sharp images. This allows the bird to make micro-adjustments to its flight path in real time, reacting to the desperate, evasive maneuvers of its prey with a latency that is almost non-existent. This processing power is fueled by a constant stream of glucose and oxygen delivered by a heart that is disproportionately large for the bird's body size, featuring thick ventricular walls capable of generating the high blood pressure necessary to perfuse the brain under extreme G loads. The predatory life of the peregrine is a constant balance of high-risk physics and high-reward biology. Once a kill is made, the falcon often seeks a secure plucking post, a high ledge, or a sturdy branch where it can safely consume its meal. Here, the specialized anatomy of the tongue and esophagus comes into play. The falcon's tongue is covered in backward-facing barbs known as papillae, which help it to grip and swallow large chunks of meat. Its digestive system is highly acidic, capable of breaking down muscle and connective tissue with remarkable speed, though it cannot digest the keratin of feathers or the calcium of larger bones. These indigestible materials are compressed in the gizzard and eventually regurgitated as a compact, gray pellet, a biological record of the bird's recent diet that allows researchers to track the health of local ecosystems. The nesting habits of the peregrine, or its eyrie, are as dramatic as its hunting style. These birds typically choose inaccessible cliff faces, high-rise buildings, or bridge pylons, environments that provide a commanding view of the surrounding territory and protection from terrestrial predators. They do not build traditional nests of sticks. Instead, they create a scrape, a shallow depression in the gravel or soil. The incubation of the eggs is a period of intense cooperation between the male, known as the tiercel, and the larger female. The term tiercel comes from the Old French word for a third, reflecting the fact that the male is approximately 1/3 smaller than the female. This size difference is a strategic evolutionary trait, allowing the pair to hunt different sizes of prey and reducing competition for resources within their shared territory. The growth of the aeas, or falcon chick, is a miracle of rapid development. Within 6 weeks, a hatchling will grow from a tiny, down-covered ball of fluff into a fully feathered fledgling, ready to take its first tentative flights. During this period, the demand for food is relentless, requiring the parents to hunt from dawn until dusk. The transition from a dependent chick to a master hunter is a dangerous one, with a high mortality rate for first-year birds. They must learn the complex mathematics of the stoop and the subtle language of the wind, often practicing with non-prey items like sticks or leaves before attempting their first true hunt. The mid-20th century, however, brought a threat that neither evolution nor instinct could overcome. The introduction of synthetic pesticides, most notably dichlorodiphenyl trichloroethan, or DDT, nearly drove the peregrine falcon to extinction in North America and Europe. This chemical did not kill the adult birds directly. Instead, it interfered with their calcium metabolism. The result was a phenomenon known as eggshell thinning. As the falcons sat on their eggs to incubate them, the shells would simply shatter under their weight. By the 1960s, the peregrine population in the eastern United States had completely vanished, and numbers across the globe were in free fall. The recovery of the species is one of the greatest success stories in the history of conservation biology. It required a monumental effort from organizations like the Peregrine Fund and a massive nationwide ban on DDT. Biologists began a process known as hacking, where captive bred chicks were placed in artificial nesting boxes and slowly introduced to the wild. Because the peregrine has a natural affinity for high structures, they began to colonize urban environments, finding that the concrete canyons of cities like New York and Chicago provided excellent nesting sites and an abundant supply of pigeons. This adaptability saved the species, leading to its triumphant removal from the endangered species list in 1999. Today, the peregrine falcon stands as a symbol of both the fragility and the resilience of the natural world. It is a creature that exists at the edge of the possible, a biological machine that has mastered the forces of gravity and the complexities of the atmosphere. To witness a peregrine in a full power stoop is to see the culmination of millions of years of predatory design, a streak of gray and white cutting through the sky, a silent testament to the enduring power of life in its most concentrated form. We continue to watch them, not just for their beauty, but because they are the sentinels of the sky, their presence indicating a healthy, functioning planet where the wild can still find a place to soar. The physical presence of the peregrine is also defined by its plumage, a sophisticated array of feathers that serve both as armor and as a tool for stealth. The feathers are exceptionally stiff, reducing the vibration that might alert prey to the falcon's approach. The dark malar stripe or mustache beneath the eye serves a practical purpose as well, acting like the black paint used by athletes to reduce glare from the sun ensuring that the falcon's vision remains sharp even in the brightest light. Every aspect of this bird, from the microscopic structure of its feathers to the chemical composition of its blood, is a part of a unified whole, a masterpiece of natural selection that continues to inspire awe and study in equal measure. To understand the global dominance of the peregrine falcon is to look at the map of its subspecies. From the massive Falco peregrinus pili of the Pacific Northwest, which hunts the heavy seabirds of the Aleutian Islands, to the tiny, dark Falco peregrinus peregrinator of the Indian subcontinent, known locally as the Shaheen falcon. The species has diverged into approximately 19 distinct races. Each has adapted its wing loading and plumage color to its specific theater of operations. The Arctic breeding tundras is pale and migratory, traveling thousands of miles each year to South America, while the Cassini of the Andes has developed a deeper chest to cope with the thinner air of high altitudes. This genetic flexibility is the secret to their cosmopolitan status. They are perhaps the most widely distributed bird of prey on Earth, found on every continent except Antarctica. The territorial behavior of the peregrine is a study in high-stakes aerial defense. An established pair will defend a home range that can extend for several miles around the eyrie. Intruders are met first with a kak-kak-kak alarm call, a sound that has become synonymous with the rugged cliffs they inhabit. If the vocal warning is ignored, the resident falcon will engage in a series of power dives intended to intimidate. These are not hunting stoops, but displays of agility and speed. If the interloper persists, the conflict can escalate into a physical clutching in mid-air, where two birds may lock talons and tumble toward the earth in a dangerous game of chicken, releasing only at the last possible second. These battles are rarely fatal, but they serve as a rigorous sorting mechanism, ensuring that only the strongest and most capable individuals hold the best nesting sites. The relationship between humans and the peregrine is most intimately expressed through the ancient art of falconry. For over 4,000 years, humans have partnered with these birds, a relationship that is less about taming and more about a mutualistic hunting alliance. In the Middle Ages, the peregrine was the bird of the royalty, reserved for dukes and kings. The terminology of falconry still permeates our language today. To be under someone's thumb refers to the leather jesses held by the falconer, and a codger was originally an old man who carried the hawk's frame or cadge. The training of a peregrine requires an immense understanding of avian psychology. It is a process of manning, where the bird is gradually desensitized to human presence through a system of positive reinforcement and weight management. The falconer does not command the bird. They provide the opportunity for the bird to do what it does best, acting as a flusher to move game into the air where the falcon can strike. In the modern era, the peregrine has become an unintentional urbanite. The skyscrapers of cities like London, Hong Kong, and Melbourne have become artificial cliffs. These environments offer unique advantages. The buildings provide thermal updrafts that the birds use to gain altitude with minimal effort, and the artificial lighting of the city allows for nocturnal hunting, a behavior rarely seen in rural populations. City falcons have been observed hunting woodcocks and other migratory birds that are attracted to city lights at night. This shift in behavior demonstrates a cognitive plasticity that is rare among specialized predators. However, Urban life is not without its risks. Glass reflections can lead to fatal collisions, and the high density of pigeons can expose the falcons to diseases like flounce, trichomoniasis, which can be fatal to chicks. The future of the peregrine is now being written by the changing climate. As global temperatures rise, the timing of insect hatches and bird migrations is shifting. For a predator that relies on a timed pulse of prey to feed its young, any decoupling of these events could be catastrophic. In the Arctic, warmer summers are leading to more frequent black fly outbreaks, which can swarm and kill nestlings. Furthermore, the encroachment of the larger falcon into traditional peregrine territories as the tundra warms is creating new, competitive pressures. Biologists are now using satellite telemetry and DNA sequencing to monitor these shifts in real time, creating a global pulse of falcon health. We must also consider the cultural evolution of the peregrine. In an age of digital distraction, the sight of a falcon nesting on a cathedral spire has become a focal point for community engagement. Falcon cams have brought the intimate life of the Eyrie into millions of homes, fostering a new generation of citizen scientists. This visibility is the peregrine's greatest defense. A bird that is watched is a bird that is protected. The story of the peregrine is a reminder that we are not merely observers of the natural world, but active participants in its trajectory. The chemical choices we make, the way we design our cities, and our commitment to preserving wild spaces all resonate through the life of this bird. As we conclude this exploration, we return to the image of the falcon at the apex of its climb. It hangs there for a fraction of a second, weightless, a master of the vertical realm. In that moment, it is the embodiment of pure potential energy. When it finally rolls into its stoop, it is not just falling. It is claiming its place in the grand architecture of the sky. The peregrine falcon is a miracle of bone, feather, and burning oxygen, a creature that has looked into the abyss of extinction and flown back out. It remains our most potent symbol of the wild, a reminder that speed is not just a measurement of distance over time, but a form of grace. Long may it shadow the earth, a gray ghost in the clouds, the undisputed king of the wind. The scientific name, Falco peregrinus, aptly describes the wandering falcon. This species travels widely, from Galapagos rocks to Greenland's peaks, continuing its long-standing role in nature. As observers of human progress, peregrines remind us that protecting them preserves the sky's integrity, allowing their remarkable speed and resilience to endure. Thank you and good night.